And the session chair, myself, Pulak Sahu, and I am from Silicon Institute of Technology. And the session co-chair is Mr. Haraprasad Naik. So, Prafula sir and Hara sir is part of Utkal University, and I am part of Silicon Institute of Technology. So, just a brief introduction. So, the first paper we would like to have presented is paper ID 7647 by Chinmay Kumar Swami. Okay. Can you hear me?
Yes, sir. Yes, sir.
So, just wanted to let you know, and everybody who has joined here, the rules that you please plan your presentation for 10 minutes, and
Yeah.
question answer would be 5 to 10 minutes. So, accordingly, you cover the 4 parts of your slides. Let's not focus too much on the introduction and all those things. Thank you very much.
So, can I share my screen?
Yes, yes, go ahead. Share your screen.
So, is it visible?
Yes, your slide is visible.
Yeah.
Have you made it full screen? Okay.
Yes,
Okay.
yes.
Okay. You can start now.
Okay. Hello, everyone. I'm Dr. Chinmay Kumar Swami, presenting the paper titled Sentiment Analysis from Student Feedback using Supervised Machine Learning Approaches. And talk outline goes like this: introduction, motivation, machine learning approaches, what we are used, and experimentation and results. Okay, so I'll finish up within 10 minutes. I'm going with my. So when you talk about the sentiment analysis, this is an approach to the natural language processing which identifies the emotional tone behind a body of text, which is also referred to as opinion mining. So when you whenever we are writing anything, okay, so there is a uh, emotional tone which is embedded with that text, okay, either it may be positive, negative, or neutral. And here our objective is to identify what is the tone which lies behind this particular text. And when we talk about sentiment analysis, it has wide applications like customer support, online brand reputation management, insights on employee sentiments, product analysis, and competitor analysis. So nowadays, people are using in various fields, okay, this opinion mining or sentiment analysis. So we had thought of to understand this its applicability in teaching and learning process. Okay, that's why we thought of to see that how students feedback will help us to identify to improve the teaching and learning process. So the motivation comes from like knowing the sentiment is very natural ability of the human being. Okay, we are trying to see that can a machine be trained to do it, can we extract some useful information out of that. Second part is which is aim of getting sentiment related knowledge, especially from the huge amount of information on the internet, because we know that internet is laden with a huge amount of text. So can we extract something useful, and we want to understand the sentiment about a topic, about a object, about a service. Okay, can we understand the opinion which are given in the form of feedbacks in the academic setting? So basically our objective is to cater the question number 3, and we are trying to understand the feedback of the students and see how we can improve the academic settings. And when you talk about the sentiment analysis area, okay, it can be like solved, okay, using broadly 2 categories, okay, using machine learning approaches and lexicon based approaches. When you talk about lexicon based approaches, here we need the help of the dictionaries. Okay, either one is a dictionary based approach, another one is the corpus based approach. In dictionary based approach, we have to use the predefined dictionary. Okay, like for example, wordnet is there. Okay, was quite popular, and from there we can extract the semantic meaning of each of the words and try to map it. Okay, whether it is a positive word and a negative word, and then we have to categorize based on the like words which are present in the body the text, and we want to identify whether it is a positive or negative feedback. Then in the corpus based approach, where we can use statistical methods, okay, to understand what is the sentiment of that particular text, and we can also use the semantic based approach using this. And when you talk about the machine learning approach, we have supervised machine learning approach and unsupervised machine learning approach. But here in this case, we are just trying to find out the sentiment of the students' feedback using the supervised machine learning approach. So we have different approaches are there: decision tree, linear classifier, rule-based classifier, probabilistic classifiers. Okay. And when you talk about our work, okay, we are just focusing on 4 machine learning approaches. Okay, and when you talk about the overall approach, which is going to be solved this particular problem, here we can capture or we can collect the student feedbacks, and we'll make some pre-processing and feature extraction step. Then after that, we'll use the machine learning based approaches. Okay, using some training data, and we'll give the output either it is a positive feedback or negative feedback. And here we use that naive-based model, SVM, n-gram-based character language model, and maximum entropy model. Okay. So let me quickly go through this each of the cases, which is very popular models. Okay. The first one is the naive-based model. Here we are trying to find out the posterior probability of the hypothesis, given that a particular event is true. And for that, we need to use that likelihood of the evidence given that the hypothesis is true into the priority probability divided with the priority probability of the evidence is true. Using this particular thing, we are trying to find out the what you can say the sentiment which is there with the body of text, and we have captured that, and we are just get. And here we are just trying to use each document. Okay, and here the document is the student feedback. Each student feedback is considered as a document, and there we have to find out the frequency of the words which we are getting from that. Okay. And we are just trying to find out the maximum likelihood of a particular class with respect to a document, and this is how the mathematical equation goes like. And this is very common term.
Just to
Yeah.
interrupt you for a second.
Yes.
Could you show us what attributes are you collecting when students are giving feedbacks?
Okay. So I think it is not in the slide. So let me just
Yeah, it's important to know what parameters you are collecting.
Can you see this slide? This feedbacks? Yeah. Just. So this is the like a sample feedback. Okay, sample feedback we are given. Okay, sample feedback. This is the feedback we got it. Okay, and we label it, okay, through the experts. And there we had collected 2 types of feedbacks. One is text feedback. The students will write based on the what they feel about the teaching learning process. And second one is they are going to quantify that one with a score. Okay, and 1 to 5 is score which is given, and 5 is positive and 1 is negative. Like that. Okay.
How many samples have you collected?
Yeah, we had collected like here. Okay, so it is there in the slide. Okay, let me go to that slide. Okay, so it will be fine for you. Total sample is 1344 students feedback we have collected. It consists of 2 parts. One is unstructured textual feedback, and another part is numerical feedbacks, scale from 1 to 5. Okay, and here we have 654 positive feedbacks, 573 negative feedbacks, and 170 neutral feedbacks we have considered. And based on that, we are just make the experimentation.
Negative feedback is for specific attributes, right?
Means No, it's not a specific category. Suppose a teacher, let me put it in this way. Okay, let me explain that particular thing. Suppose a teacher is teaching a particular subject. Okay, we just want to understand that what is the feedback of the particular teacher. Okay, when he teaches that particular subject. Okay, so there the student will give its feedback. Okay, then
On 7 criterias.
uh, uh,
For, for
not on seven criteria. No, it's not like that. It's seven samples we had given over here. Okay.
so students are giving feedback on free form.
Yeah, free form.
They,
Okay.
they can type anything.
Yeah. They can type, which is given here itself. If you look at here, okay, these are the feedbacks. Okay. So, for
So
example,
they just write their impression on a teacher in whatever language they
yes.
Okay, and when like what is the cutoff between positive and negative?
So we had thought of that less than 3, 4, 5. We had taken up to the positive one, and 1, 2 we had taken as the negative one. Okay, and that feedback they had given. Okay, the student also gives that feedback also. Like it will assign that what is the, they will give it in the textual form as well as the point form also.
Can you please directly go to your results?
Okay.
Experimental results.
Okay, this is experimental results. Okay, so this is the table. Can you see this one?
Yes.
Yeah. So we have accuracy, precision, recall, and F measure. So whatever we had collected, okay, using those data set, and here we can see that accuracy of SBF is 92%, and N-gram is 69, maximum entropy 62, naive base is 54. And when we are
Accuracy means out of the complete data set, you have taken some as test,
yes, and some
some
are
as a
training
training,
and some are tests. Yes.
and then you are predicting whether positive or negative.
Yes.
So to two-part classification that you are
Yes.
doing.
Yes.
So okay. So here, yeah, naive Bayesian is pretty low.
Yeah.
ME is also in apart from the first case, it is low.
Hmm.
So SBM-RB is something which is giving good
Yeah,
result.
better result. Yeah. But when you are considering the neutral classes,
Hmm.
sorry, this is the first table which says that when you are considering the neutral classes without considering, with considering the neutral classes,
Hmm.
you are getting this accuracy. And if you are not considering the neutral classes like positive and negative feedbacks, we are only considering, then we are finding that little bit better accuracy.
Okay. My final question before we wrap up
Yeah.
is that why you have selected naive Bayesian, ME, Ngram, SBM-RB,
Mhm.
some other techniques that are available.
Yeah, the techniques are available. Actually this is done by one of my student. Okay, so we had just thought of to let's do some experimentation. Maybe in the future we can just extend this particular thing to apply some good techniques so that we can improve upon this particular model.
Or my suggestion would be that when
Yeah.
you do literature survey,
Yeah.
you will know what techniques people are using normally
Yeah.
in this kind of domain,
Hmm.
and you have to include the most commonly used ones, and your one will be some kind of say hybrid technique or something.
Yeah. That yes.
Which
You
is
are
giving
just you
I'm just
rightly
giving you
pointed out.
idea for when you present, when you send for a journal or something. There you have to do a comparative
Yes.
study.
Yeah, that's very
Otherwise,
good idea. Actually. I
yeah.
appreciate that one. Yeah, I
Otherwise,
also yes.
yeah. Otherwise, everything is fine.
Mm.
So time is getting almost over for you.
Yeah.
So thank you.
Thank you, sir. Thank you.
Bye.
Bye.
Hello. The next person is uh, Susrut Mishra from KIT and paper ID 1046. Are you there?
Yes, sir. Hello. Good afternoon, sir. Sir,
Uh,
actually, Shushruta sir is absent, so I'll be presenting on behalf of him.
you are a co-author on
Yes,
this?
sir. I'm a co-author on this. Yeah.
Okay, then certificate will be given to your name.
Okay, sir. Sure. Yeah.
So fine,
Yeah.
whatever. Now 10 minutes presentation and question answer. Then after
Okay,
that.
sir. Sure. Yeah.
Okay,
I'm
we
just
shall
presenting my screen.
cover the core parts.
Yeah. Okay. Please let me know if I'm if the screen is visible.
It is visible.
Okay. Yeah. Thank you. So, hello everyone. Good afternoon. I am Shuham Chakraborty. I am a student, BTech student from KIT University, Bhubaneswar. So, I will be presenting on the topic COVID-19 outbreak estimation approach using hybrid time series modeling. So the contents I'll be covering today will be introduction, then background on time series data. Then I'll be introducing you all to the ARIMA model, LSTM model, and the proposed model that we have written in this research paper. And then I will talk about the implementation and results. And finally, I will conclude the presentation. Okay, so coming to the introduction. So since the end of 2019, the novel coronavirus pneumonia has swept the world, causing serious damage to the global economy and people's lives and properties. Through scientific research analysis and through continuous medical clinical analysis, relevant experts have concluded that the new COVID has highly contagious and follows a pattern that we can find a trend in that to understand the increase and decline pattern with respect to time frame, and we can identify that to understand at what time the COVID-19 trend will break or will come down. So generally it is found that they are forwarding from one person to another person can be represented with the help of nonlinear systems. So we have found that in the previous studies using the data driven method, either linear or nonlinear components have been captured, but it doesn't suffice as it has both the components together. So we have proposed a model by combining two models, which helps in understanding both the linear and nonlinear aspects of the data. Okay, so I will talk about the background of time series data. So time series analysis comprises methods for analyzing time series data in order to extract meaningful statistics and other characteristics of the data. Time series forecasting is the use of a model to predict future values based on previously observed data,
Yeah,
while regression.
this one you can
Yes.
skip. Uh,
Okay.
let's go to
Next,
core
I will
part.
next I will introduce the two models and finally the combined model which we have proposed. So ARIMA model stand for autoregressive integrated moving average. Different ARIMA metrics are autoregressive constituent. This metric is represented as P. If P equals to 0, no autocorrelation in the sequence is noted. If P equals to 1, it signifies presence of autocorrelation in the sequence of the data. So the current data will be dependent on the previous data that we have. Integration part is the specialty of ARIMA model, which distinguishes it from the ARMA model. So in the ARIMA, the integration is represented by D. If D equal to 0, it signifies that the set is stable and we don't require to make the difference. If D equal to 1, it signifies the set not to be stationary. So if the data is stationary, it will follow a same mean and same variance across the data. But if it gets non-stationary, then the mean and variance changes gradually. So to bring it to the linear structure, we have to differentiate between each position of the x-axis so that we can get a linear curve, and based on that we can apply the ARIMA model. So moving average constituent, it is denoted by Q. In moving average, the moving average Q equals to 1 signifies an error and time autocorrelation is there. And decomposition, it relates to dividing the time series into trends, seasonal impacts and residual variability. Okay, so now I will introduce to the LSTM model. So LSTM is an improved version of RNN model. So it basically introduces some of the gates which are not present in RNN, which basically takes input the sequential data and outputs the variable like the label variable. So the unit in the hidden layer of the LSTM network is a linear self-circuiting shortage, which allows long-term preservation of the gradients. Okay, so now coming to the proposed model. So due to the great uncertainty of the epidemic data and existence of the linear and nonlinear trends both in the data, the linear prediction model is greatly limited when we are using it alone. So however, the machine learning prediction method has a better accuracy. So we proposed a combination of the ARIMA and LSTM neural networks. The ARIMA LSTM model gives weights to the ARIMA and LSTM models respectively, which usually use the equal weight average method. We use regression coefficients as model weights. So as we can see in the formula, so y will be the label equal to the W0 W1 into LSTM value plus W2 into ARIMA value. Since linear regression can retain the linear trend of ARIMA and the non-linear trend of the LSTM model, the predicted value of ARIMA, the predicted value of LSTM, and the real value are linearly regressed to realize the prediction of the real value. Okay, so here we can see the structure of the proposed model. So we get the COVID data, then we process the data and pass it to the ARIMA model for fitting it, and then we train the LSTM model over it. And once it calculates the predictions over the data, we multiply it with the weights accordingly, with W1 with ARIMA and W2 with LSTM, and we finally sum them up. We get the weighted average to get the final prediction. So in the right, we can see the validation matrix. We have used different type of error matrix as well as the accuracy score. So you can see MAC, RMAC, root mean square error, MAP, R2 score, and MAE. So as we can see, combined model gives the better accuracy compared to the LSTM ARIMA as a standalone model. And also the R2 score also, although it is same as the LSTM, but the error comes down in case of the combined model. Next, we are coming to the implementation and results part. So from the inference part, we infer that out of 100% of most affected group in between the age of 20 to 29, we have approximately 25% of the total cases, while the least cases have been found in the group of old people having age above 80. The people between the ages group 30 to 19 occupy the second position to easily get affected with 21% of the total cases. Next comes to the age group of 40 to 49 people having 16% of the total cases. We found that the total number of confirmed cases along with the recovery is increasing exponentially, while the death rate is increasing slowly with respect to time. From the graph, it can be referred that the total number of cases by the end of August 2020 has reached 35 lakhs all over the world, which is very threatening. But one good thing we can gather from the graph that recovery rate is also increasing, so we can hope for the best. In second figure, we compare the situation of few countries facing global pandemics like China, US, Italy, Spain, France, and India. So from the graph, we can find that total number of cases in India and US are increasing, while countries like China, Italy, and France and Spain have temporarily controlled their condition. So total number of cases is increasing in a bit slower rate than the other two. Okay, prediction using proposed model. It is the hybrid model as we discussed by using ARIMA and LSTM network. By using the combination of both models, we produce.
So sorry to interrupt.
Yes, sir.
How recent is this data?
Sir, actually, it is from 2020 data we have done. So it is a research from a previous time. So,
So I think for this paper you need to get the latest data.
okay.
2020's data is, if you see latest data,
Mhm.
India is doing much better than the countries you mentioned.
Yes, sir. Actually, it was the time when it was just starting. So we did the research on that time. So yeah, we can of course we can add the this part as well in the paper. So yeah, we will look into this in the next phase.
We can tolerate in recentness up to 6 months. Not
Okay.
like 2 years. 2 years is not much useful to us.
Sure, sure. Okay, sir. So we can add it in the next phase of this.
Other thing is that
Mhm.
what your model saying is that young people are more susceptible to COVID.
Mhm.
Uh, Actually, young people supposed to have better immunity than older people.
Yes, sir.
And so, why is that? Any analysis have you done? Why younger people are more affected than older people?
So basically the reason is not found, but the analysis is done only on the data level. Like the data we had only said the age groups.
But you're just presenting the output.
Yes, yes, the inference from
Reason
that.
you are reason you are not researching.
A reason actually, yeah, it's not covered here.
Okay, so any other person would like to ask any questions? All online participants, anybody? If not, you can stop your presentation.
Okay, sir.
Thank you.
Thank you.
Paper ID 913. Paper ID 913. Sudipta Priyadarshini. Are you there? 913 Sudipta Priyadarshini.
Yes, sir. I am audible.
Yeah, audible. Go into the full screen mode.
Yeah, go to the full screen mode
Okay.
and
Okay.
and the presentation time is 10 minutes. Then after that, question answer session. So try to cover the important parts of your.
Okay, okay, sir.
Thank you.
My name is Sweta Piosni and I am going to present the topic machine learning algorithm for diabetes prediction. This is my contents. And machine learning is a technique analyzing data that automates learn and improve data models without explicit instruction. It's a branch of artificial intelligence based on the idea that computer system can rely on pattern with minimal human intervention. The basic concept of machine learning is to get computers to program themselves over time by collecting data and then to react and act on it. Diabetes has emerged as one of the most deadly.
Hello.
Hello.
First go to the presentation mode, then present.
Presentation mode रे तो अच्छी sir.
Press F5.
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 फुल स्क्रीन नहीं की.
नहीं फुल स्क्रीन नो से जो प्रेजेंट एटा पावर पॉइंट ना.
हाँ हाँ.
You first present.
अच्छा ओके पर F5 प्रेस कर ली. Okay, so diabetes has emerged as one of the most deadly and prevalent illness in the modern society, not just in India but also everywhere else. The process of detecting or predicting diabetes disease from patient records is known as diabetes disease diagnosis. And diagnosing diabetes disease is a difficult.
Which slide? We are just seeing the title slide, first slide.
Acha, first slide. But I am in third slide.
Okay. So first you have to go to the content of your presentation, then talk about all these things.
Okay, this is my contents. First is introduction, then literature review, then methods used, then result discussion.
Okay, hold on. We are stuck in slide number 1. So why don't you unshare and share again? And when you share, the slide should be in slideshow mode. So slideshow mode is when you press F5, then you share. Okay, got it?
First F5, then share.
First you share your screen. No, not share. First press F5.
First press F5.
So now you are in full screen mode.
Okay, F5 press.
Then you share. Go to Alt tab and press Alt tab, and then share option will come. Then you press share. Press F5.
F5.
Function plus F5.
What?
Press function key plus F5 key together.
Yes. Now?
No, you go. You look at the नीचे जो है task bar, नीचे का जो बार है
नीचे सर फंक्शन प्लस F5 I press. Slide is not visible or what? सर स्लाइड कौन देखा जाउनी की?
अरे स्लाइड देखा जाउची प्रेजेंटेशन बोले सी आरो नेक्स्ट स्लाइड को केमि आसीबो? You don't know how to present your slide in the PowerPoint?
ना I know. But
Then
I5 तो प्रेस करिछि मु.
Listen to me. The problem is that even though you are going to slide 2, 3, 4, we are only seeing slide number 1 all the time.
अच्छा.
Understood the problem? So
हाँ.
you are in the design mode of PowerPoint.
अच्छा.
So if you press F5 or below right hand side, there is a small box kind of icon. If you press on that, it will go into full screen mode. Then your cursor will work and it will take us to the different slides. So F5. Okay, now we are able to see. You continue the presentation. A lot of time is lost.
Okay.
So continue.
Okay, this is my contents. First is introduction, then literature review, then methods used, result and discussion. Last is conclusion, and last is reference. The machine learning is a technique of analyzing data that automates learn and improve data models without explicit instruction. It is a branch of artificial intelligence based on the idea that a computer system can rely on patterns with minimal human intervention. The basic concept of machine learning is to get computers to program themselves over time by collecting data and then to react and act on it. And then diabetes is emerged as one of the most deadly and prevalent illness in the modern society, not just in India but also everywhere else. The process of detecting or predicting diabetes disease from the patient record is known as diabetes disease diagnosis. And diagnosing diabetes disease is a difficult task that necessitates experience and knowledge. The enormous volume of information that can be acquired with the use of digital gadgets can be combined with machine learning technique to diagnose and predict disease. Different classification methods are employed in medical data mining to predict diabetes disease in patient. And this is my literature review. In the first paper, the SVM, NAP-based ADA boost and decision tree methods are used. And the conclusion is that ADA boost algorithm achieved an accuracy of 80.72%. In the second paper, in my reference, the methods are used are NAP-based decision tree, artificial neural network, and SVM. And the conclusion is that decision tree, NAP-based, and SVM approaches all offer precision of 85%, 77%, and 77.3% respectively. In this third paper of reference, the author used the convolutional neural network, and with CNN, the author obtained the accuracy of 77.98%. This is my proposed methodology is that in order to predict diabetes illness, we have used 5 classification approaches such as extra tree, random forest, decision tree, KNN, and passive aggressive classifier. For this study, 20% of data are utilized for testing, and while 80% of data are used for training. After applying machine learning algorithm to the data set, the accuracy rate was computed, and the main objective was to find an algorithm that could classify the given data set most accurately. Then description of data set.
Yeah, that's fine. What I'm saying is that this particular paper, this particular work, many people have done. Lot of work has been done in this cancer or diabetes classification.
Huh.
And if you go back to the previous slide,
Okay.
go back to previous slide.
Hmm.
One more, that previous slide. Next slide, next slide. So here you have, not that one, next slide. Here. So here you have used extra tree, random forest, decision tree, KNN. So
Yes.
these techniques have been used so many times in these situations. So what is unique here? I mean,
Unique is that I set the hyperparameter of the algorithm. Hyperparameter table is that default parameter already set in the algorithm, but I just changed the parameter in which the
Based on what?
accuracy is
Based on what?
accuracy means based on accuracy increases. I just change the parameter, hyperparameter.
Is
Just test
it
trial.
you're using hit and trial method or any smart method to set the
The smart
parameter?
method, hit and trial method. Many methods are there. Random search technique, grid search technique now there, but I'm just hit trial method. Using just some hit trial method and changes the hyperparameter.
For
And
example,
the accuracy is increased.
Like random forest parameter is 1, 2, 3.
N estimator I
42.
take 500, max depth of 5.
How do you know 1, 2, 3 is the best one, 42 is the best one? How do you know?
Nah, I just hit and trial method. Na? So I first 42, I am trying 42, 1, 0, 101. I am just trying in which method.
Oh, you are not using hit and trial. You are recursively trying different parameters in a for loop, and whichever is giving the best one, so that is not hit and trial.
Actually.
So you have to say, I have iteratively used
Iteratively.
in the range of this, and I found.
Actually, iteratively. Actually, I just, iteratively, I just.
Go to the last slide where you have which one is giving best accuracy.
Random forest and extra tree.
Okay.
81.16%.
Extra
And
tree.
actually, बहुत सारा method, many methods are also there to choose the best parameter, like random search technique.
But you are supposed to go through literature survey and find out which common methods are being used. So you create a new method and you compare with the highly used methods by other authors and show that your method is giving better accuracy. Understood?
Understood. In literature survey, I just gave the literature survey of below the 81.16%.
So, okay.
ମାନେ ସବୁ ଯେତେ ସବୁ ଦେଇଛି ମୁଁ 81.16 ରୁ କମ ଅଛି literature survey ରେ.
Oh, ठीक ଅଛି. Your presentation time is over, so you can unshare and stop the presentation.
Thank you.
So next is 2084 Susuta Misra.
Good afternoon, sir. Sir, I'm Niyati Mishra, one of the co-authors. I'll be presenting on behalf of Sushruta, sir.
Niyati Misra. Okay.
Thank you, sir.
Then share your screen first.
Sure, sir. Sir, is it visible?
Yes, it is visible. Your presentation time is 10 minutes. So try to discuss the most important parts in that.
Okay, sir.
Thank you.
Good afternoon, everyone. Today I will be presenting on the topic estimation of rice yield using deep learning. The proper and effective estimate of rice seed helps strengthen national food security by ensuring timely export and import decisions. It thereby helps the management help make proper decisions regarding which superior varieties of crops they need to cultivate in order to incur maximum profit. It also helps farmers and cultivators to make informed and financial decisions. Now, deep learning has emerged a front runner in this field, and many deep learning techniques have been used. And even in this study, in this paper, we have proposed one of the deep learning framework or techniques. Here we come to the literature survey. We have mentioned few of the papers that have used deep learning techniques in order to estimate the rice yield. In one of the paper, they have proposed a novel deep learning framework for yield estimation and prediction of winter wheat yield, and they have particularly used meteorological data and two remotely sensed indices, that is the leaf area index and the vegetation temperature control index. They have used LSTM or long-term memory neural network, and they have added a feature of attention mechanism to it, which helps them segregate the essential input sequences that have maximum impact on the target vectors or the output vectors. In another such study, they have the authors have proposed a model which is enhanced by the application of deep learning technique, and it helps not only with yield prediction but also provides accurate estimates of the amount of soil ingredients required along with the respective expenses. Now they have incorporated machine learning and deep learning together, like they have used SVM as the machine learning algorithm and LSTM and RNN as the deep learning algorithm. So hereby, after looking at few of the researches, we come by to the problem definition of FAR study. That is, the precise and timely prediction of crop yield information is crucial for making accurate decisions, agricultural decisions, and non-expendable decisions that have a direct impact on the country's economy. And deep learning has shown promising results in this study. However, there are still certain challenges associated with using deep learning with rice yield estimation. These include integrating various interdependent factors into the model for better results, incorporating prior knowledge with existing knowledge. So in this paper, we have tried to tackle some of the existing issues, and we have proposed a LSTM-based framework in order to provide more accurate and faster crop estimation results. So basically, we are proposing an LSTM-based network. Let me tell a bit about LSTM. It's a variant of RNN or recurrent neural network that helps overcome the primary problem that RNN faces, that is the vanishing gradient problem. LSTM and LSTM unit, it largely comprises of a cell, input gate, output gate, and a forget gate. While the cell is responsible for keeping track of values over random instances of time, the three mentioned gates, they help regulate the flow of data into and out of the cell. In this study, we have made use of a data set comprising of various soil parameters such as soil pH, bulk density, soil organic carbon, clay fraction, soil nutrients such as the nitrogen, phosphorus, and potassium, farmyard manure, and rice yield for all the 314 blocks of state Odisha collected by NRRI Cuttack Odisha. And we have made use of the LSTM network with the input shape of dimension 1,12, which is run for 100 epochs. The batch size is chosen to be 10. Root mean square is chosen to be the loss function, and activation function is chosen to be ReLU or rectified linear unit. So once the data is fed, it is divided into a set of training data and testing data, that is 70% training and 30% testing. Then it is fed to the network, and then we get the estimated results for both the training and testing data, and we calculate the root mean square error in order to have an idea about the performance. Now, coming to the results section of our study, here we have procured that our training data is RMSE score of 0.07, while the testing data is RMSE score for 0.21. So we know that the lower RMSE score indicates the said model is a
Can
comparative.
I interrupt for a second?
Sure, sir, sure.
Yeah, the results, so if you give in a tabular form,
Yes.
it looks better than in descriptive form.
Yes, sir. Sir, I'm coming forward to it.
What you have written result is actually conclusion where you describe.
Yes, sir. Okay, sir. Okay.
So
Thank you.
first you give the data in tabular form, then you describe in textual form.
Sure, sir.
Yeah, better to use bullet points than this paragraph kind of structure.
Okay, sir. Sure.
And just one more question.
Sure.
Why, who told you to select 70% as the training data and 30% as the test data?
Sir, that I have taken on on a whim. Like, no, it's not like I have it's just I've taken for randomly.
Okay, so randomly, if you have taken, there would be, suppose you would have taken 80-20.
Sir, I have tried also with 80 and 20 and getting similar results.
Okay, another way is n-fold cross-validation. Have you heard about that?
Sir, validation I have heard. N-fold cross-validation I have heard of it. Yes, sir.
Yeah, basically your test data will be, suppose you are using 20% of the test data for the test data, that 20% will change. First, you suppose there are 100 instances are there. You use first 20 records first time and see the accuracy. Second time, use the second next 20 records. Third time, next 20 records. Like this, if you do, and take an average of the accuracy. So you have basically done four-fold cross-validation.
Yes, sir.
You understand your test data and training data will change 4 times, and you take an average of the accuracy.
Oh, yes.
That is a better measure rather than just randomly 70-30.
Definitely.
And you must justify, if you are publishing in a reputed journal, you must justify why 70-30.
Okay, sir. So thank you.
Okay, so I think we have got whatever work you have done, we have understood it. If nobody has any questions, we can move on to the next person. You can unshare.
Okay, sir.
Next paper is 7748. Mohit Kumar Singh. Are you there,
Yes, sir.
Mohit Kumar Singh?
Yes, sir, I am here.
Share your screen.
Sure.
7748. Share your screen.
Sir, is it visible?
No,
Okay.
not yet visible.
I'm sharing again, sir. Now,
Yeah, it is visible now.
okay. So, myself Mohit Kumar Singh. I am a research scholar in JP Institute of Information Technology, Noida, and my topic of presentation is orthogonal chip division multiplexing, which is an emerging multi-carrier modulation scheme. So in this presentation, I am going to cover the background, a brief introduction of OCDM, compatibility of OCDM with the OFDM, that is orthogonal frequency division multiplexing. Then, being in multi-carrier modulation scheme, OCDM also suffers from the high PAPR. So we will discuss some PAPR reduction scheme also. Then I will talk about the computational complexity of OCDM and applications of OCDM, and I have performed some simulation results also to check the performance of 3 PAPR reduction scheme, and I will show the simulation results. And last, we will conclude the PPT. So as we move towards the 5G from 2G, one of the common things that have remained is increase in data rate. This data rate increase is made possible by MIMO, that is multi-input and multi-output scheme, and MCM, that is multi-carrier modulation. In case of MIMO, that is multi-input, multi-output, it is an antenna technology for wireless communication in which multiple antennas are used at both the source and at the destination as well. And in case of multi-carrier modulation, data is transmitted by sending over a multiple carriers, which are commonly closed space. And one of the most widely used multi-carrier modulation scheme is OFDM, which is the key technology for 4G communication. And OFDM is what is recently proposed in 2016. In OCDM, the modulation principle is based on the use of a set of N chirp signal, which are overlapping in time and frequency, and they are mutually orthogonal. And we can use the amplitude and or phase of the chip signal to modulate the information. So we can use the either quadrature amplitude modulation or phase shift keying or QPSK for the modulation of information communication. As shown in the figure, a bunch of chip waveform overlap temporally and spectrally in the OCDM in the direction of, and they are mutually orthogonal. As similar to the OFDM, in OFDM, discrete Fourier transform is the fundamental key aspect behind the OFDM. In case of OCDM, the key aspect behind the OCDM is fractional transform, and digital implementation of OCDM is possible using discrete fractional transform. And we can realize the OCDM with the OFDM transmitter with the minor modification. I will show how we can implement the OCDM with the OFDM system. So in case of OFDM, we are using discrete fractional transform. The discrete time OCDM signal is given by the equation where x is equal to phi raised to power hs. H represent here Hermitian transpose, that is a complex conjugate. S represent the information carrying symbols vector, X represent the OCDM symbol, and phi represent the discrete fractional transform matrix, which is given by the equation number 2. Equation number 2 represent the discrete n cross n discrete fractional transform matrix. And if we the well-known OFDM signal is given by equation number 3, where y is equal to Wn raised to power minus nk multiplied with x, where y is the OFDM symbols and Wn raised to power nk is the discrete fractional transform, discrete Fourier transform matrix, the DFT matrix. The n cross n DFT matrix is given by equation 4. If we compare the equation number 2 and equation number 4.
Excuse me, sorry to interrupt. Could you please explain the meaning of orthogonal chirp, CHIRP? What is that?
Chirp is a signal which change its amplitude with the time. It's like a frequency modulated signal. And orthogonal means they are orthogonal to each other, and they are non-overlapping.
No, just chirp. CHIRP, it is pronounced chirp or chirp?
Chirp, CHRP.
So chirp is like bird making sound, right? English,
yes, sir.
English meaning.
Yes, sir. Yes.
Chirp, birds are chirping. Means in the morning, birds are making random sounds. That is called chirping. So here, is it related to that one, to this topic?
No, it is not related to the word, sir. Actually, chirp is a type of signal which change its, I can say, angle with time.
Okay.
So,
okay, continue.
Okay, thank you, sir. So after inspecting the equation number 2 and 4, we can say that we can find out the discrete fractional transform by using the discrete Fourier transform, and with 2 additional quadratic phase, which are given by equation number 5 and 6. So anyone can find the discrete fractional transform using DFT by following the 3 steps. For that, they have to first multiply the signal with the quadratic fix phi1, and then they have to perform the discrete Fourier transform, and after that they have to multiply the signal with the second quadratic phase, that is phi2. So we can In the next slide, I will show the implementation of OCDM transceiver using the OFDM transceiver, where we have used these two phase factors, phi 1 and phi 2. So here, we have shown the integration of OCDM in the OFDM signal. If we exclude the boxes in blue color, then the system will behave like a OFDM system. And if we include these boxes in the system, then the system behave like a OFDM system, OCDM system. So in OCDM, because we are including two complex multiplication, so it will increase computational complexity of OCDM as compared to widely known OFDM. So as OFDM was suffering from the high PAPR, that is peak to average power ratio, OCDM also suffers from the high PAPR. And in literature, it is mentioned that different PAPR reduction scheme which were proposed for the OFDM can be applied to the OCDM also. And selective mapping, that is SLM, and partial transmit sequence, that is PTS, are very attractive PAPR reduction schemes due to their good PAPR reduction capability without the restriction on the number of subcarriers. But in that case, in both the scheme, the transmitter has to send the side information. Side information is nothing but the phase rotation factor. So different scheme, if we are sending the side information from transmitter and to the receiver end, then it will reduce the spectrum efficiency, utilization of the spectrum. And it may be possible that side information may get corrupted during the transmission. So it will not be possible in that case to recover the original information. So different schemes have been proposed in the literature to avoid the requirement of sending side information to the receiver. Multi-point square mapping combined with PTS, that is, and concentric circle mapping combined with PTS is what two of them. In case of multi-point square mapping, the information carrying symbols were mapped to mapped on the vertex of a square. As shown in the table, we have used a quaternary data, that is 0, 1, 2, and 3, and we have mapped 0 to on the vertex of a square, that is 3 plus 3j. We have mapped 1 to another vertex of the square, that is -1 plus 3j. Similarly for 2 and 3. And after applying the PTS, and PTS perform the rotation with phase factor 1, -1, j and -j. After rotation with phase factor, that is 1j, -1 and j, the rotated symbols will be on the vertex of 4 squares. So that's why this scheme is called as multi-point square mapping. And for the detection of information from the mapped symbols at the receiver end, the demapping has to be performed, which is shown in the table. For if the symbol received, or we can say the constellation point received, is from the is lying on the vertex of a particular square, then it will be demapped to a 3 plus 3j, that will represent nothing but the quaternary data 0. And if is lying on the vertex of another square, then this will demap to the -3 plus j, and that will nothing but to the recovered data or quaternary data 1.
Okay, so you have done literature survey on this. So some recent work must have been done on this.
Yes.
Producing some performance or accuracy or resilience. So how is your technique in compared to the existing techniques that have been carried out in the literature survey or by other experts?
Yes, sir. So
Where it is making the difference? Can you pinpoint?
Yes, sir. These schemes have been proposed for the OFDM. We have applied these schemes on the OCDM, and we have shown that the performance of OCDM with respect to the OFDM is better, because OCDM is immune to the channel impairment. Therefore, the performance of OCDM is getting better as compared to OFDM if we are applying any of the scheme which has been proposed in the literature for OFDM. So we have shown in this paper that OCDM which is a multi-carrier modulation scheme, is a better scheme as compared to OFDM, which is widely known and widely used in 4G communication.
Okay, your time is up. So we have got it. So unless anybody else has any questions who are there online or offline, uh, anybody has any questions for him on this presentation? Okay, so in this case, you can stop your sharing.
Okay.
Thank you for presenting.
Thank you, sir. Thank you.
Okay. Next paper ID is 6946. Samya Misra.
Yes, sir. Sir, very good afternoon. Should I share my slide?
Yeah. Please share your screen first.
Yes, sir. Sir, is my PPT visible?
It is visible now. Start sharing.
Go to full screen mode.
Yes. Yes, sir. Sir, is it fine?
Okay, we can see it.
Okay, sir. Thank you. So, a very good afternoon to the esteemed panelists and my fellow participants here in the conference. This is Soumya Mishra, and I'm very grateful to ICIICC 2022 to accept my paper on comparative analysis of COVID-19 detection from cough speech using machine learning
Could you
classifiers.
please speak up?
Uh,
Unable
okay,
to hear.
yes, sir. Sir, am I audible now?
Yes, now you're audible.
Okay, sir. So I thank ICIICC for accepting my paper. Now, basically, I will be focusing my presentation on this content. Well, as we all are aware, the COVID-19, also known as the coronavirus disease, is still an ongoing global epidemic caused by severe acute respiratory syndrome, coronavirus 2, or we call it as SARS-CoV-2. The novel virus was first identified in an outbreak in the Chinese city of Wuhan in December 2019, and all attempts to contain it was brutally failed, allowing the virus to spread in other areas of Asia and later worldwide. And a couple of months after, the World Health Organization declared this outbreak as a public health emergency, and in almost in January 2020, and later it was coined as pandemic on 11th March 2020. So, as far as 13th, almost up to 13th December 2022, it has already claimed more than 6.65 million confirmed death, making it one of the deadliest in history. So, as we all are aware, COVID-19 symptoms range from undetectable to deadly, but most commonly it includes fever, dry cough, and fatigue. Why it rapidly spread across the globe within the shortest span of time, because it was relatively new disease and there was no faster testing mechanisms at that point of time, and it really took a lot of time for the radiologists, for the other technicians to pace up with the rapid increase of this disease in such a short span of time. So basically, as we all are aware by now, that coronavirus disease severely impairs the upper and the lower respiratory tract, and in a particular healthy candidate, the oropharyngeal microbiome is a different set of community microorganisms residing, but in case of a COVID-19 patient, the oropharyngeal microbiome is severely altered, and inhaled SARS-CoV-2 particles likely infect different epithelial cells types on their way to the distal lung. And once this initial viral contact occurs in the nasal mucosa, then the viral S spike protein to the angiotensin converting enzyme receptor, followed by cleavage of S protein by TMPRSS2, is basically going to trigger an immune and inflammatory response manifesting in clinical signs and symptoms of COVID-19. So these inflammation and impairment in the voice tract functions must cause changes in the voice signal produced. And basically, my objective here was to find these changes, quantify them, and use them for COVID-19 prediction. Now, one important thing to note down here that although we had many existing testing capabilities at that point of time, which I really commend the medical fraternity to come up at a fast pace within 2 or 3 months, we had different testing mechanisms, but somehow it really compelled the suspected candidate to breach the social distancing norms, so the candidates had to visit the clinics, the hospitals. And we also came across many reports saying that certain candidates who were suspecting they might be positive, they might not be positive, but they were became confirmed positive upon exposure in the clinic and the hospitals.
Excuse me.
Yes, sir. Yes.
We have spent quite a bit of time on introduction.
Okay, okay. So I
Can we
will go
move
to
on to the real work?
Yes, sure. So basically, sir, here my target is to come up with a non-invasive speech-based COVID-19 detection. So I have performed many literature review on various speech-based disease detections, including Parkinson disease, dementia, oral cancer, and somehow I have just listed here a few COVID speech category, which I have actually compared with my methodology here. So as we can see here, based on my existing literature survey of using exclusively those features which I have used in my method, we have got the highest accuracy of almost 82 to 89%, which has been shown by the global feature extracting the spectral descriptors here. Yes, these all are within my literature reviews, and as I have compared my work against these literature reviews. So without wasting time, I'm proceeding towards my methodology. So yes, this is me. This is my solution approach. So I have used basically a set of 13 feature vectors and simple spectral descriptor audio features. I have taken three standard corpuses, that is Kafvid Koswara from Indian Institute of Science and TDD Cambridge database. So I had to literally sign an MOU with the University of Cambridge to get hold of this database. So this is a brief description of my three databases which I have used for my
So
study.
this data you obtained from where?
Sir, KDD Cambridge I have obtained from University of Cambridge. I had to sign an MOU. Koswara has been obtained from Indian Institute of Science. And CUFWID is also a part of a published journal. So I have obtained this data set from the link mentioned in the
So
journal.
you have merged the data from various sources.
No, sir, I've compared the results with the three individual databases in order to get a uniform conclusion.
Okay, next question is that I do see some zeros, NA like this. So have you like
Yes, sir, I'm
this
coming
missing
to.
data?
Uh,
Pre-processing is
Yes,
done
sir.
on this?
Yes, sir. Actually, here the NA has been not applicable, has been written for used language. So basically, the Cambridge and CUFWID, they only contain cough samples. So basically, the patient only has to record his cough. So for that reason, there has been no indication of the used language here. But under Koswara, we have different data sets for cough, breath, and speaking of vowels. So for that reason, I've used the
What I notice is that all the three attributes are mixture of alphanumeric, numeric, and all kinds of things. So I mean the attribute type is varying.
Attribute in the sense, sir, you are talking about
For example, in the first column, the attribute values are integer, then floating point numbers, then text.
sir,
How does the model I mean accept this?
sir, is my slide lagging? Currently, I'm in the solution approach.
I am not very sure that machine learning can handle this kind of variety of data types. You can have Different
Sir,
data type.
the data types are dot wave audio files, sir.
Okay.
Hello.
After pre-processing, how your data looks? Do you have a snapshot?
Sir, I don't have the snapshot for this paper, but in a couple of other research, yes, I have taken
So,
out because
so
I
you
have
have
gone
to
through
shown the raw data, not
uh,
processed data.
actually, sir, I have not presented here. I have gone for the pre-processing followed by normalization and then going for the audio feature extraction.
What kind of normalization you have done?
Sir, simple normalization, just
Which
dividing.
normalization?
Sir, very standardized normalization. The data point divided
There are
by the maximum.
various types of normalization, min max normalization, G score,
Uh,
Z score normalization. So
Sir,
what
it's a
is,
max. It's a max normalization. Yes, sir.
huh?
It's a max normalization.
Min max.
Yes, sir. Min max, right? I've gone for a very simple type of normalization, pre-processing followed by normalization.
So you must mention these things. We have used these techniques.
Uh, yes, sir. Yes, sir. I
Okay,
think
go
that.
move to the next slide.
Okay, so followed by a couple of audio feature, I've extracted the audio features, sir. The features are as such, that is the spectral centroid, which represents the center of gravity of the spectrum. Next is the spectral spread, which represents the instantaneous bandwidth. Based on the spectral spread, again, we have gone for the third moment, that is the which gives us the symmetry, that is the spectral skewness. It measures the symmetry around the centroid. And the spectral kurtosis, again, that is the fourth order, so that measures the flatness or the non-Gaussianity of the spectrum. The spectral entropy, which has been very instrumental for taking successful classification decisions for voiced and unvoiced sounds in ASR. Spectral flatness, which indicates the peakiness of the spectrum. A spectral crest is an indication of more tonality, and spectral flux is popularly used in the onset detection and audio segmentations. Spectral slope measures the amount of decrease of the spectrum here. Spectral decrease again represents amount of decrease of the
So all these
spectrum.
things you are calculating.
Yes, sir. Yes, sir. This has been
Where is the
individually
result?
done. Yes, sir. I'm going to this.
Result is there in tabular form somewhere.
Yes, sir. It has been it has been recorded in the tabular form. Just a minute. Yes. So I have analyzed the results for individual three databases, sir, comparing five machine learning classifiers.
There you had given number of calculations, parameters. You have
Yes, sir.
given, I,
So those has been extracted in 13 feature vector forms, and I have recorded that in a single Excel sheet, and then I have processed. So together they are known as spectral descriptors. So spectral descriptors or baseline perceptual features, they are normally extracted together in a form of 13 feature vectors. And apart from that, if we go for MFCC and
yeah,
GPC,
DB1 and DB2 are two different sets of data.
yes, sir. DB1 is Koswara from Indian Institute of Science. DB2 is another very huge database, that is CUFWID. And third is DB3, that is KDD from University of Cambridge. KDD.
So when you are merging three sets of data, you have to make sure that they are measured in the same scale.
Sir, I have actually not merged. I have extracted the features and have classified them individually. So my results have been recorded for individual databases.
Okay,
Just to,
training testing data set, what proportion?
sir, 90-10.
90-10.
Yes, sir. And I have also gone for k-fold cross validation. K equals to 10.
K-fold means tenfold.
Yes, sir. 10 folds. 10 folds. Yes.
Tenfold, and you have taken the average.
Yes, sir. I've taken the average.
Okay, thank you.
Uh,
Anybody has any questions for us? Online, offline? Okay, thanks a lot. Bye.
Okay, sir. Okay, sir. Thank you.
स्टोरेज में ढेर दिया नहीं थी तो ऊपर
you.